Greetings and welcome, friends. We were in section 3.1. We're talking about functions, page 108, big ideas, algebra 1. And I'm going to show you some problems from the homework to help you out. So, I'll just be in your ear telling you how to do the math. It's going to be great. And also, you've got light coming at you, speed of light into your eyeballs. Your brain is processing it with your neurons. It's going to be good stuff. You're going to figure this out. These patterns are amazing. See, it says determine whether the relation is a function. Explain. Okay, so a function had exactly one output for every input. In the case of ordered pairs, our input was the first number and our output was the second number. We also frequently call ordered pairs x and y, x comma y. So if I input 1, I get -2. If I input 2, I get 1. If I input 3, I get 6. If I input 4, I get 13. If I input 5, I get 22. Every input had exactly one output, right? I would have been suspicious if for some reason I had two inputs that gave me separate outputs. But in this case, this is a function. I'm calling it function. All right, function. Question 5, let's see, here's an input-output chart sort of thing. So if I get 0, I get -3. If I said 1, I get 0. But if I asked you, when I say 2, you say, the audience would have been like, 3, 2, both, through, tree? Is tree the combination of 3 and 2? I don't know. Here's the problem. This is not a function because this 2 is giving me multiple outputs. So not a function, right? Good times, good times. Over here, here's an input-output table, similar to this, except now it's arranged kind of in a table, little boxes, cells, wonderful. Let's see, so is this a function? -3, 1 output, 0, 1 output, 3, 6, 9. Well, all of these give 1 output, so that's a function, 1 output for every input. Question, friends, what if this was also 11? Would that have still been a function? Yeah, because outputs are allowed to repeat. Inputs, so to speak, are not allowed to repeat, right? I can have the same output come out multiple times as long as each input only points to one thing, okay? But I don't care if there's multiple outputs, so good times. All right, let's keep moving here. Question 9 through 12, specifically 11, we'll narrow it down. Determine whether the graph represents a function. Explain. So do you guys remember we talked about the vertical line test, that if a vertical line hits more than 1 point, look at this vertical line, that only hits 1 point. So this is a function, right? No, because I can think of multiple vertical lines that, bam, 2 hits. Right, multiple hits. Yeah, so that's not a function. And when we're thinking about these graphically, the x-axis here are my inputs, the y-axis are my outputs. So notice if I input 2, I would have gotten both 2 and 4 as outputs. That's multiple outputs for one input. That's why we do this vertical line test. We are fine with horizontal lines, by the way, when it comes to functions. Horizontal lines are great. Okay, here we go. Here's some new lingo language. It says find the domain and range of the function represented. So domain were the possible x values. So it looks like this one has, I'm just plotting the points for the possible x values. The domain in this case is the set -2, 1, 0, 1, and 2 by the looks of things, right? That was almost, yeah, I don't know, I'm keeping it. So that's my domain. The range is what I would get if I mapped these onto kind of the y-axis. So this has a -2 output. Then I had a 0 for both of these points. You can't really see them anymore because I colored over them. And then I've got 2. So the range, or the possible outputs of the function, so that would have been, looks like -2, 0, and 2 were the possible outputs. So when I'm asking domain and range and looking at a graph, I'm kind of just visualizing what x values occurred and what y values occurred. So let's see, domain for this. So on the x-axis, it looks like -4 was a possible input all the way to +2. and everything in between, right? Do you guys kind of see how that's where the graph exists? If I was to like step on this and smoosh it down to the x-axis, that's what I would get. So I'm going to say the domain is the set of all x such that -4 is less than or equal to x is less than or equal to 2. All right. And let's see, let's talk about range. So the range, if I was to smoosh all of this sideways and all of this sideways into the y-axis, if I just like did like my hand press and just like smushed it, it looks like the biggest number I get is 6. The lowest number, is this the lowest number that I get? You guys agree? Is this the range that I'm drawing here? Well, what about this point? This point exists. That's an output. Or this point exists. Just because this was kind of where my graph ended didn't mean that's where my range ended. So at one point it went as low as this. So it looks like my range is all of that. So the range, in this case, the possible outputs are the set of all y such that y is between, let's see, let me make sure I got my scale right. If that's 4, then 1, 2, 3, 4. Each box represents 1, and that is 2 is less than or equal to y is less than or equal to 6. All right, so domain and range. That was a good problem. I like that one. Also, we'll talk about this one today. Actually, neither of these would be what we'll talk about today, linear functions. Oh, here we go. Vending machines. Feed me, robot. I'll feed you money if you feed me food. Let's see. You select items in a vending machine by pressing one letter and then one number. Okay. Explain why the relation that pairs letter number combinations with food or drink is a function. So if I type A1, I'm getting popcorn, right? Pop. If I type A2, I'm getting nuts. Nuts. This is nuts. If I type A3, I'm getting pretzels, right? And then let's see, B1 gives me that, B2, B3, B4. Hey, I get the same output twice here. Apparently these folks are juice fans. Is this okay that if I kept continuing this, is this okay that C1 gives me the juice and C2 also gives me the juice? Is that still a function? Yeah. I'm never going to like type in A2 and then like I asked for that and then it's going to give me like something else. What did that say? Oh, protein bar. I thought it was chocolate. But no, this is the chocolate bar. So yeah, so this is a function because for every input, which is what we're doing here, I'm getting exactly one output, right? This will fall out of the machine and then I pick it up out of the machine. Let's see. It says identify, we haven't talked about this yet going over this homework assignment, the independent and dependent variables. Independent and dependent variables. So you guys remember what the independent variable is? That's my input, right? So independent is the number letter combination, or the letter / number combo, right? That's what I'm inputting. And then the output is the dependent variable. So dependent is the food. Okay, I like it. All right, and then it says find the domain and range of the function. So the domain are the possible inputs. Let's see. We might not take time to write all of these. So the domain is going to be the set of all A1, A2, comma C2, comma C3, right? It's all of those. And the range is going to be, what was it? Popcorn. It's going to be cereal. It's going to be everything all the way down to milk. right? Good stuff. Actually, guys, I'm looking at this machine. This is actually pretty smart because I was like, okay, wait, if they've got milk in there, I hope this is refrigerated. I hope so. But also look at the intelligence of how they arranged this, because hot air rises and cold air sinks. Notice they put the items down here that need to be more refrigerated, whereas up here, I don't care if my popcorn is hot or cold. And so the cold air is kind of like cooling down here, and then even like here, it's still a little bit cold where, it'd be nice if my chocolate bar wasn't melty. But then up here, it doesn't matter as much. So they actually even sorted this pretty intelligently. I like that. All right. So keep your milk cold, friends. Thanks for watching. Have a great day.